Hi, everyone. This is a new podcast, a new session where I bring you someone who is amazing human being, an amazing person who's putting a lot of hard work and a lot of hours out there in the open source space to make sure he has a mission. And his mission is to bring a million person to understand machine learning, artificial intelligence, especially in this day and age where the tech industry kind of did its own kind of reset and it's trying to kind of reform itself and mutate into this new kind of day and age where intelligence is at the core of everything. I want to introduce you to my dear friend, Professor Vijay. How are you doing, Professor?
I'm great. Thank you so much for having me. I'm super excited to be here. I'm hoping we can share a little bit of wisdom with all the wonderful learners you have here.
Absolutely, absolutely. Professor, just tell us a little bit about yourself, your beginning. I know that there's a lot more to unpack there, but you're a professor at Harvard and you still take the time every day to sit down and contribute a 2,500 plus pages book for people to learn machine learning accessible to everyone everywhere free of a charge. What's that about? Tell us a little bit about you. Who are you? What are you about? Go ahead.
Yeah, I think the best way to kind of do that is to really kind of take people back to kind of where I came from, because those roots really have a deep resonance with what I actually do today. And so, I was born in India, in a small town called Vishakhapatnam that's on the southeast of India.
Uh-huh.
I was there until about like middle school, and then my parents, thought I should try getting educated in Singapore, which is a slightly different, ecosystem. So
Mhm.
I was there pretty much most of my teenage years and so forth. I actually grew up there, and I started my college at the National University of Singapore. And then I moved. My parents had moved to the United States, so then they wanted me to spend time with my brother. So then I moved to the West Coast, where I did my undergrad. I continued my undergrad at Santa Clara, a small Jesuit institution that's phenomenal.
Nice.
And then I joined the PhD program at University of Colorado Boulder. I finished up with a master's, and then I moved to Harvard. So I actually did my PhD. I finished my PhD in computer science actually at Harvard.
Nice.
And
Nice.
then I went to University of Texas at Austin, which is where I spent about 7 to 8 years as a faculty member in the electrical and computer engineering.
Mhm.
I did a
Mhm.
sabbatical at Google for a couple of years, and then after that, we decided we'll come back to the East Coast because my wife is actually from here. So that's
So
kind
you
of my like life journey, and
uh-huh.
we kind of step through this chat here. It will come back to that threads. I want people to have a little bit of context about life, because who I am is very much tied to where I've come from. Right?
Yeah,
I've had really
absolutely.
cool beginnings, and so the
So
thing that we're here to really talk about is sort of like this machine learning systems textbook
uh-huh.
that I've been working on. And
Mhm.
really, as much as it's a textbook, it really started out of just class notes. It was just, I used to teach this online course over COVID. It's called TinyML, right?
Mhm.
Basically about deploying machine learning on embedded devices.
Mhm.
Now,
Mhm.
certainly, I think like that kind of really lit up the space in my head, which is when you look at AI and ML, you hear ChatGPTs and all this fun stuff.
Yeah.
We all get it. We know it can tell a cat versus a dog. It can greet us and all this stuff. But there's an
Not hot dog. Hot dog, not hot dog. Go ahead.
but there's an element that's kind of fundamentally missing, right? It's like learners don't quite understand what it is, because you're not going to go build a chat GPT tomorrow,
Mhm. Mhm.
right?
Mhm. Mhm.
Um, Yet, if you kind of look at the fundamental educational system where we've all come from, where we learn about computer engineering as a discipline and so forth, there's been a very systematic pedagogical training of engineers.
Mhm.
And I think
Mhm.
there is right now what we're actually seeing is this. You've got, think about this, like historically, you've got computer science. Right?
Mhm. Mhm.
Then you had electrical engineering at the lowest level.
Yep.
Right?
Hardware, bare metal. Yeah. Mhm.
You know how to think about the theory.
Yep.
But we as a community back in the 1970s,
Mhm.
even before I was born, a
Mhm.
couple of very
Mhm.
clever people thought, looks like this piece of technology is actually something, if we specialize in building this one piece of technology, computers, it has the potential to completely revolutionize society.
That's right.
The
That's
last
exactly
50
right.
years, we've been in that, holy grail of like, building better computers, better computers.
Yeah.
So that was done because we trained an entire lineage of engineers
That's right.
known as computer engineers.
Yep. Yep.
I
That's
would
right.
argue that, like, over the last, 50 to 70 years of AI innovation, it's really been quite algorithmic in capacity. It's really been about computer science. And so the
Mhm.
question that I have for us is like, how do we train the next generation of AI engineers right? It's like you
Hmm.
had computer science, then we did computer engineering as a discipline across the world.
Yeah.
So in my head, it's really about building the next generation of engineers. I think people
Nice.
don't realize that how much of chat GPT and all this fun stuff is actually very relatively speaking, right? Not to be dismissive, but to
Mm.
relatively be speaking, is a very simple algorithmic standpoint.
That's
Algorithm,
right. That's right.
a massive engineering effort. And I think
Yep.
that credit to all the engineers is kind of lost in the hype of AI just being this brain
Yep.
kind of thing.
That, that,
That's
that,
really where we are.
I mean, usually that's the thing about products in general. Like, think about if you go out on a street and ask anyone about who Steve Jobs is. Everyone probably would know. Then ask them about who's Dinesh Ricci is, right? Which is the guy behind the C and C plus plus, the C language with Thomas Thompson and all that. People wouldn't know who that is, right? So you can tell there like the brains behind what's actually out there. Products are usually very loud because that's what people use every day. Okay, I use Chrome, so that's Google or Alphabet or whatever. But the theory behind the web and being able to load content on the web and all that, that's a whole different thing. So
Mhm.
so so you're on a mission to make sure that the new generation, okay, so people used software engineers, and then the whole industry is elevating, it's doing a reset, and it needs a whole new brand, whole new species of software engineers, which is AI engineers. What are those? Describe them to me. Like, what are they like?
Yeah.
Right.
So that's a
Mhm.
good point. All right. So let me just kind of clarify one thing there, right? When you said this on,
Yeah.
we're gonna have AI engineers, but AI engineers in my head are fundamentally different from like say data science people,
Yep.
right?
Yep.
We still very much need these ML theory experts and all of that good
That's
stuff. It
right.
needs to
That's
get
right.
taught. All
That's
I'm
right.
saying is that there's a complement to it that's really not emphasized, and I think that's just a disservice that we have done to ourselves.
Mm-hmm.
Which is kind of like it's one thing to have like a transformer and know how
Mm-hmm.
to sketch it out on paper and understand, the
Mm-hmm.
KV caches and the queues and all that good stuff. But it's
Yep.
another thing to actually know how you realize those matrix multiplications very effectively on a finite resource, which is the
That's
hardware,
right. That's
right?
right. That's
And
right.
that
Mhm.
is, I argue, is going to be in 2030. It's going to be one of the most hottest industries. That's my
Exactly.
best bet because this we know this train is basically going to continue,
Yeah,
right?
its trajectory is obvious. Yeah, exactly.
But
Uh-huh.
it's the engineers who are going to be really needed. Now that engineering stack spans through traditional electrical engineering,
Mhm.
computer engineering, and all I'm saying is right now we've got a new evolution, like as you kind of just laid it out, right?
Yeah.
Is that whole notion of AI engineering, which is like, how do I build a machine learning system?
Yes.
That's the
Yes.
key word, is the system element, right? And I think
Right.
that is definitely something in the industry. The industry knows this really well. There's a
Mhm.
good reason, like, people are hiring like lots of engineers right now to build the
That's right.
mega data centers and so forth, right? That are going to consume
That's
massive
right.
amount of power.
That's right.
But all of those are really being done by engineers and not really being done by the science side of the people.
That's right. That's
Right?
right. That there's a theory, then the practice there. But
Yeah.
is an AI engineer someone who's like right now a software engineer? I've been spending most of my life as a software engineer, and I didn't care much for hardware, right? It's a cloud, deploy to the cloud, let it run in the cloud, and enterprise applications, go ahead, 1, 2, 3, 4, and you have a web app or an enterprise system. But now you're talking about a kind of type of engineers that is more hardware aware plus software and theory. So there's the theory, the software, and the hardware. Is this what an AI engineer is essentially?
It would
Mhm.
be it's really no different than how it's been traditionally done. Think about it, right? Yeah,
Yeah,
we have a distributed Kubernetes cluster, let's say, right? Okay, what does that really fundamentally assume? Well, Kubernetes is a particular type of runtime environment, we could say.
that's right.
Well, that whole thing is orchestrated because we got Linux or Windows or whatever your
That's
platform you're
right.
running it on, right?
That's
You
right.
take
That's
that
right.
for granted and you just magically assume that this distributed OS is 1000% like, just kind of sitting there, always, robust and, failure proof,
Yep.
right? All
Yep.
of that then assumes networking infrastructure is all magically working, right?
That's
And
right.
all of that
That's
on the
right.
base plate of hardware. So
That's right.
all of those system layers that we have taken for granted, which I think is a good thing. Whenever you take something for granted, it means it's doing its job well, right?
Yes, that's
Engineers,
good. It's silent. It's not causing any trouble. Yeah, that's a
yeah,
good thing.
I think they're doing a really good job, right?
Uh-huh.
I think when it comes to like machine learning systems, it's very much the same thing, right? We're
Mhm.
taking all of that stack and then we're adding a whole bunch of nuance about it, right? It's a different runtime. The fundamental
Uh-huh.
triangle is you got to understand how you deal with the data engineering pipeline,
Mhm.
right? And when
Mhm.
we're dealing with massive amount of data, there's an entire teams dedicated for just data engineering pipelines,
That's right.
right? How do
That's
we
right.
feed the beast, which is the compute engine? In
Yes.
order to move all of that, of course, you've got these models that are consuming things, right? So you've got data movement. So these are all systems concepts that we understand. However, the language has changed a little bit in the sense that because of how these networks work and so forth, now suddenly you just have to adapt and understand, okay, this is the language, right? Oh, when I do
Mhm.
tensor parallelism, this is what it means.
That's
It's
right.
going to put the pressure on these different subsystems. But
That's
what
right.
does it really mean to quantize? And these like these numeric things, these have historically existed in signal processing and other areas.
That's
I
right.
think what's particularly challenging about machine learning systems is that it's this amazing intersection of different fields. And that's what is one, very exciting for someone like me.
Mhm.
And
Mhm.
two, teaching it is also quite challenging because
It's a
you
whole
have to
new
have so much
yeah.
more knowledge in the
Yeah.
background, right? But I
So
think
the
that's what's really needed, right?
so you're basically saying, to get into that phase, a prerequisite is required. You can't be an AI engineer just from the get-go. You have to understand the concepts and the principles and the fundamentals of, software engineering in general, data in general. Validate this for me. Let me just throw this at you and see what you think, right? I feel like to get into that phase and that era of AI powered system, you need to understand data, you need to understand compute, and then you need to understand integration, like how you make AI take actions, open the garage, buy me something from Amazon and whatnot. I feel like these three pieces are important. What's missing there? Are these really all that it takes? Understand data, compute with algorithms and LLMs and whatnot, and then how to make this thing take actions and actually go do things that are more than just saying hello world to
Yeah.
you. Mm.
Yeah. I think you're touching on something quite important. I would say the best analogy I can give you, Asana, is going to be like, think about the brain. We're so
Uh-huh.
fascinated with the brain right now,
Yes.
right? We should
Yes.
absolutely be fascinated thanks to what everybody's worked and created so far. What I genuinely think the next wave of this is going to be
Hmm.
is the realization that the brain is pretty much a useless potato if it sits by itself.
That's right.
I
That's
mean by
exactly right.
that
Yeah.
is
Uh-huh.
that you really have to systematically focus on building the nervous system that connects to that brain, because without a proper integration of that nervous system, you
Hmm.
don't really have the brain being useful. I
Hmm.
think
Hmm.
there's this element of like, oh my God, like we have all this capability is what people are focusing on. But I think like this infrastructure that kind of bleeds out into the physical world, I think is one of the most interesting areas, which is what you were touching on, which is the actuation side of things.
That's right. That's right. The material
I think that
actually do
actuation is
something.
where
Yeah.
we don't
Mhm.
quite have it down, but I'm sure we'll figure it out. I mean, these models are making great progress, right?
I wanted to ask you about this. The biggest problem, like I'll tell you the commercial side of AI and you tell me, right? The non-deterministic nature of it is quite pain. I mean, as a software engineer, we could hack all day long, right? We could hack the heck out of it. Like we could go and say, okay, with this prompt, I want that specific JSON object or tune now. People are not going for JSON now. They want to go for tunes because it's a lot cheaper. That's
Yeah.
classic enterprise software engineering for you, right? I don't want it to cost too much. I want to go at the end of the quarter and tell my manager, hey, I saved us $300,000 in tokens from Claude because I'm using tunes.
Yeah.
I want to ask you this. This is I really need to know this. And I'm pretty sure a lot of people listening to this, especially people who have already interacted with AI, have gone through that pain. Are we approaching it the wrong way? Because see, as a software engineer, you're still thinking in terms of zeros and ones, right? It's either a right answer or a wrong answer, right? And I expect to input a name and it says hello name. But with LLMs, you're saying you enter a name, I'd be like, hello name, how are you doing? The next time you do it, it'll be like, hi, how's your day going? Not even mentioning the name. Are we looking at it the wrong way? Like this deterministic nature of machines, is that era is over? And we're
Yeah.
into more like, go ahead, go ahead. Hmm.
Beautiful. Oh my gosh. I actually spent a couple of months thinking about this and I just wrote, a short piece for CACM. Um, the title is English is a Programming Language. Okay.
Uh-huh.
computer science people will explode on this and say like,
Yes.
oh, this is the dumbest idea. This will never work. In fact, Dijkstra, back in the 1970s,
Yeah.
said
Yeah.
thinking of English as a programming language is a fool's sort of errand. Like, he literally calls it the foolish thing to be doing back in the
Yeah.
90s.
Yeah.
Now, this is where you have to kind of think about this difference between what needs to be truly precise and
Mhm.
what is inherently, sort of like something that ties things together. So let's say
Mhm.
we're building traditional thing, right? Building a website, you want precise behavior, you have to get the network bits right, like everything has to be precise.
That's
When
right.
you're trying to do something very specific, yes, you need formal guarantees, you need grammar, you need a syntax, you need to be able to verify and validate it, right?
Mhm. Mhm.
Now, I'm going to say that that aspect is going to continue. I doubt we're ever going to throw away, like, the benefits of, programming languages.
Yes, that's right.
I think when computer science people get worked up about it is like, because I think like, they think, oh, we're no longer, we're saying that we no longer need programming languages. That is not true. What we
Uh-huh.
really do need are programming languages. However, when you think about where we are going now, is like the whole level is kind of like abstracted one level up.
Yep, you're going
Now,
one
what
one
we're
up,
in the
one
era,
level up.
we know how to
Mhm.
build the silos. That's what we have done incredibly well for the last 50 years, let's say.
That's right. That's right.
Now,
Compilers, machine code, and now you have high level. Mhm. Mhm.
now we're kind of getting into this point. We're doing orchestration. I
That's
don't
right.
think we want agents to necessarily spit out the perfect bits because they're inherently, not precise,
Not
right?
not precise. Yeah. Mhm.
That's
Mhm.
okay. What I think they're incredibly good at is like you need a programming language to connect different components together, right?
Uh-huh.
Because some
Uh-huh.
things are going to be written in Python, some things are going to be written in C, some things are going to
See,
be written
whatever.
in
Yeah.
Rust.
Yeah.
There is no universal programming interface. So think about it as an API. So when
That's
you have an API, you have a clear definition of what you're going after in
that's
terms of
right.
interfacing with it.
That's right.
What we now need in order to take all these systems which use APIs is you need a universal programming interface that can connect this. And my bet, this is where I
Distinguished.
argue that
Mm.
English is that universal programming language that allows us to rely on that UPI mechanism. And we have not yet cemented this idea about a UPI, whether we
Uh-huh.
need it, how do we structure it, right? I
Mhm.
mean, think about
Mhm.
it like a USB protocol, right? I mean, a
Mhm.
USB stick is amazing, right?
Yep. Yep.
But we
Yep.
haven't quite realized that. And I think like this is where when we start thinking about what is the role of these programming languages and how we think about these AI systems, they are effectively elevating us to the next level. And
Mhm.
we are a perfect example. For once, I think we're actually on the right mission. We're actually getting computers to do what we want them to do. We have
Mhm.
always thought we're getting computers to do that. No, the reality is we are doing what computers understand. That's what we have historically done.
Yes, that's right. That's
Now
right.
we have finally progressed to the level where the machine is truly starting to work closer to us. We are nothing but a computer, right? Whenever
Yep.
I'm talking to my daughter,
We're
I'm
computing.
constantly
Yeah.
giving her instructions,
That's right.
constantly
That's
giving her
right.
instructions, right?
That's
And
right.
English is the language.
Yes, it is. Yes.
I think that's that mindset. So I don't think we're actually going about it wrong. I think we're just going about it like we're realizing that okay, we're in a different era right now.
And we need to kind of adjust and understand where we can benefit from it and where we can. It's like when NoSQL was first introduced. I remember the hype, right? I remember when people said, "Okay, forget about relational databases. We're just gonna put files with stuff in it, and it has a reference." And people were like, "That will never work. That's too abstract. That's too whatever." It's just the closest thing I can think of. But it's crazy that you just said that because I was just talking to a bunch of engineers literally this morning about if people continue the trend of vibe coding, and I really want your take on that one, eventually you're going to end up with like 5 years in the future, you're going to end up with people who don't really understand programming languages. What they understand is prompts. You talked about English and whatnot. And at that phase, shouldn't we just let the LLM talk directly to the machine code, to the hardware? I know that's crazy and very dangerous. I'm just throwing some thoughts at you and
No,
see what
no,
you
you're
say
speaking
about it.
like how an academic thinks, right? We are usually free of these kinds of, what's tomorrow, it's got to work in the product tomorrow. So I fully agree with you. I think like how many of us truly understand assembly language? I still understand assembly language because it's my job, right? I got to
Yep.
teach the kids to kind of build things up from it. Yeah, so therefore
Yep.
I understand the assembly language of, certain ISAs.
That's right.
How many of us understand it? I still, wipe code a lot now, right? Like obviously
Yep.
wipe code even more now. It's like because
Yep.
we all do it because now
Yep.
suddenly we're able to be that much more productive. Now,
Yep.
often when I'm looking at it, for instance, when I'm using cursor, I'm often like, thinking about it. It's like, man, it's like I'm like looking at assembly language. Why am I looking at assembly language, right?
Uh-huh.
And often,
Yeah.
if I interfere with that damn assembly language while I'm doing the white coding, it actually throws the model off because I'm
That's right.
interfering with its chain of thought, right?
That's right.
So I think it's
That's right.
like an interesting sort of a progression. It's like, and this is where we have forgotten what true computer science and education really is,
Mm,
right?
mm,
So Janet Wing, back around 2006, she was a professor, I believe at CMU or Cornell. I could be mixing it up, but
mm.
she wrote this article, very short article about computational thinking.
Uh-huh. Uh-huh.
Computer science, if you look across the world, is almost sometimes taught in the wrong way. What I mean by that is that if you miss a semicolon, you will lose points literally on an exam for that. I
Mm-hmm.
remember that like yesterday because I remember at NUS going back home, I lost points for missing a semicolon and getting syntax wrong. But I was like telling the TA, I was like, I thought the whole point was algorithmic. So why are you
Yeah,
telling
to solve a problem like pseudocode, right? Why do you care about
Yeah,
semicolon or any
clearly
of
my
that?
algorithm is correct. Like I'm
Yeah.
wow again. And he was like, well, it's like wrong. It's like that's how we grade it. And I was like, this is ridiculous. This is not what computer science is.
That's
Right?
right. That's
And to
right.
this day, we are still dabbling with that. And so coming back to that, like if you realize that what computer science is, it's about the pseudocode, it's about the higher abstraction thinking. Now, when we go to these models, I think we need some sort of analogous sort of a mapping, which is like machine reasoning, or I don't know what you want to call it, like
Mm-hmm. Mm-hmm.
some natural language programming concepts. That how do you sort of interact with these machines, right? What are the fundamental concepts that you should
Mm-hmm.
really know to do and not to do with these systems? And I don't think we have codified that. And I'm not saying like, I'd be able to do this, but I believe somewhere there is a fundamental principle or science about interacting with these systems. And I think all of this is going to be unraveling. And the funny thing is, I think most of the people who are building these systems are far too busy actually building the systems to have the time to sit down and write about these systems.
That's right. That's the thing. If you're actually building something, you're way too caught up into materializing it. You wouldn't have the time to actually explain everything. But like later, I'll
Yeah.
explain later. I mean, the most common thing in the engineering industry, software engineers do not care about documentation. They just if you want to punish an engineer, tell them go update the documentation, right? That's the thing. I mean, it's very possible in this day and age that okay, the things that we dread the most, like if a software engineer dreads writing documentation whatnot, an LLM or an AI agent could help do that. Be like, just keep going, and I'm going after you, unless it's something that AI can't just kind of explain, too novel, too new, too specific, that it just doesn't know how to explain. That's still possible, right?
hmm Yeah, I mean, I think it's possible, right? At the end of the day, it's like, it's obviously seeing connections that are very hard for us to kind of, understand, right? Because it's operating in a much higher dimensional space, right? And I think like at the end of the day, it's still all in the data. But the reality is it's just in distribution, right? It's working off
Mm-hmm.
whatever distribution it's seen before, right?
Mm-hmm.
I think
Mm-hmm.
the only
Mm-hmm.
thing that and, people say like, oh, like humans are truly intelligent and like, like there's this. I'm like, it's like, okay, yeah, I'm a Harvard professor, but look, let's be real. I'm here because of all the people who invested in me and who helped groom me
That's
and
right.
train me and all that. So this brain here is actually
A
an
lot of
execution of my
work.
history, of where
Yeah,
I grew up, who I
that's
came
right.
through, my professors who kind of elevated me, and all of that. So for
That's
me,
right.
I'm like, I feel like, in all honesty, maybe I'm putting myself down, but it's like I feel like I'm pretty much like an LLM. Do I hallucinate? Yeah. Well, let me think about it. I just make up something and say, well, I'm not sure about it, but I think this is the thing.
That's
Like,
right.
so I kind of feel like we're very similar in that. Like, we're in we operate within the distribution that we know, right?
Mhm,
If
mhm.
I don't have experience, I mean, I've traveled most of the world, right? Like, kind of like gone through. That has given me a very rich set of experiences.
That's right. That's right. You get to see the whole breadth, the whole plethora of how
Yeah,
really diverse and different we are in so
yeah,
many different
exactly.
ways. Mhm,
But yet, despite that, I've never really spent time in Europe.
mhm, mhm,
So if you
mhm,
ask me culturally or the Middle East, like
mhm,
culturally and so forth, I'm still pretty ignorant, right? So my
mhm.
point here is these systems are very much like us, right? It's like whatever is kind of like, in their training data, which we all never seem to find out what is actually in the training data. I mean, I feel like
Okay,
my history is my training data, and so is yours,
okay,
right?
okay. So let me just ask you this. Okay, a lot of software engineers will be watching this podcast, right? And I'm just looking at the work that you've been putting out there. It's quite amazing actually, but the most important part about all this is that like you put that massive amazing, I'm going to share the screen here just with people to see what I'm talking about. You put this massive book that is just amazing. And um is this the start? Is this how you advise people to start into machine learning? I mean, I feel like you haven't left anything. You just
But
go
the
ahead.
reality is that I would say, like, again, like, I'm in a very humble way. Like, I think like what Andrew Ng did,
Mm,
with his original course, right?
mm,
I think
mm,
like what he did was an incredible thing, which is like he really brought the whole notion of machine learning to people and made it accessible in a way.
mhm, mhm.
However, that's on the theory side of things.
Yes,
My interest in what we're doing in this resource is really to try and help people understand, okay, you've got the theory. Now, how do you kind of think about the system side of things?
that's
And
right. That's
that's
right.
sort of the fundamental thing is like I'm kind of focused on. So it doesn't fully cover everything, obviously, but it covers the engineering side of the machine learning. And so that's
Yes.
what I've been really passionate about. And the reason I put this down is because, even my own colleagues, even when I teach the class and so forth,
Mhm.
and my colleagues at Berkeley or Stanford, Harvard, we all end up kind of teaching our own little areas of expertise. And what
That's
I
right.
was realizing was that, guys, when we learned about computers, we weren't thought about memory systems. We weren't thought about caching. We weren't thought
That's
about
right.
compute execution, data path design, all in isolation.
That's
Right?
right. That's
The
right.
classic book that I go back to is like this is the computer organization book, right?
Nice.
The old
Nice.
school
Yes.
Ian Patterson textbook. I mean, I remember reading this over a summer just because I was just like, wow, so this is how a whole computer is actually put together. Right?
Uh-huh. Uh-huh.
These books have left such an impression on me that I learned, like, you know what? Yes, these are complicated systems, but
Uh-huh.
you
Uh-huh.
can distill them into like individual components and help people see the big picture first before you get them to dive into the details, right?
That's right. That's
So
right.
that's what I felt was like really missing when people are talking about these things is like they're not breaking the pieces down and saying, here's the jigsaw puzzle.
It's
Everybody's way
actually where it is.
in the
Uh-huh.
detail.
Uh-huh.
And so I wanted to pull back up. And this is one thing I've just generally found that I find very, very easy, which is that I can easily see the connections between different topics.
That's beautiful.
That's
Yes.
always been my uniqueness in research and so forth too. So
Yeah.
that's what kind of led to this book, in all honesty. It's because I
So
really felt like that was missing.
is it fair to say like a book like this, Vijay, would basically give people really the lay of the land, the bits and pieces that makes a smart system intelligent, right? An intelligent system intelligent. And actually, as curious as you can go, the book won't kind of let you down. The book will continue to give you more as you get curious. I
Yeah.
feel like, yeah. Mhm,
It
mhm.
does go from the very basics of how we think about AI systems and so forth.
That's
And
right.
one of the first ones I actually talk about right in the introduction is the bitter lesson from Richard Sutton, right? Who's
Mhm,
the
mhm.
Turing Award winner for reinforcement learning. Who basically wrote that look, you can come up with the most sophisticated and complicated algorithms. And
Mhm.
reality has shown that it's actually the very simple algorithms coupled with insane amount of compute that actually gets these things to work in production.
Yep.
And
Yep.
so that's one of the things that I motivate with is like, this is what the godfathers of the field in a way are saying is like they're
Yep.
realizing it's actually the AI engineers who are actually unlocking the capabilities at massive scale.
That's right.
I
That's
feel
right.
like all these AI engineers, their visibility is completely lost in the AI hype right
That's
now.
right. That's right. That's exactly right. Yep.
And so
Mhm.
one of the reasons I wanted to kind of get through this was to kind of help people understand, hey, there's an entire ecosystem around this that you can get into and you can specialize. And like questions that even my own PhD students, when they're graduating nowadays, are like, well, okay, like how do you implement a multi-head attention network? Like, okay, I bet you a lot of people have no freaking idea how to do that.
That's right.
They
Yeah,
know
of course. Yeah.
all that stuff, right? They know
Yep.
how to import like, torch
A
and do
library and whatever. Yeah.
that's
That's
fine.
right.
That's totally okay. There's nothing
Yep.
wrong with it. But
Yep.
I'm just simply saying there's a handful of people that they're actually building the nuts and bolts underneath all those calls, and we need more of those.
That's right.
That's the
So
thing. So
is this why you want to make 1 million of them? Like your mission is to bring 1 million. I mean, I see where you're coming from. Like, we need as many AI engineers in the world today as much as possible for so many different reasons. One of the biggest reasons, like from my perspective, like someone told me this once, like, well, I guess nobody's going to be working anymore. I was like, big question on engineering, because if this thing goes rogue, engineers are going to be the only people to stop this thing from getting any further or any worse. But really, tell me, why do you want 1 million out there, just giving that all love, just all that knowledge out there?
I mean, the reality is because I feel there's incredible talent across the planet, right? But opportunities are severely limited.
That's
That's
right.
part of the event, right? The fact that I'm here, right? It's because I'm super fortunate, and stars had to align so perfectly, as my mom
Yep.
would say, right, for me to be
Uh-huh.
here.
Yep.
But I'm sure there are just as many people as just as passionate and just as capable whose stars didn't quite align just as perfectly, to be honest.
Yep.
And that is something like, the opportunity that I have here is like, it's not something I take for granted.
Mhm.
And so, like, when I see talent, I just kind of feel like, oh my gosh, I came, yeah, I came from India and so forth. And I told you the story about me kind of, growing up in different places. So I always had this thing like, okay, we all come from these amazing countries and we never quite give back.
That's
It's
right.
something I just personally have started, maybe it's like, as my kids are starting to get slightly older and so forth, I'm starting to realize, oh, it's like it's more
Yep.
than about just about me. It's also like, what we give back to community.
That's right.
But one of my big interests in kind of doing this outreach and so forth is this book and so forth, and maintaining it open source has been like, just kind of, oh, this is my way of giving back.
Of giving back to the, yeah,
People might
yeah,
not understand this, but you remember the whole George Floyd stuff that
yeah,
happened?
yeah, yeah.
At one Saturday, I remember when all that stuff was happening. One Saturday, my wife and my older kid back then, there was only one of them, we went to get breakfast. And I remember going about around this roundabout, and I just remember this African American family. To this day, I remember they were just like standing there, and there was one of the young kids who was just the same age as Nora at that point, holding like a paper cutout thing saying like Black Lives Matter. And I remember telling my wife that night I had a hard time sleeping because I was just kind of thinking, this is a ridiculous world we are in today.
That's
Why
right.
kids
That's
have to
right.
be fighting for this? I'm like, no, I want the kids to be
To
kids,
focus on
right?
growing and be kids and actually enjoy life, instead of like having to worry about how the adults have failed,
Yeah,
essentially. Yeah, yeah, yeah.
that that is from where, like, then we started doing this TinyML course because I realized, like, what can I do? I was like, okay, I can go out and hold a poster board too, right? That is
That's
important.
right. That's right.
But I kind of felt like, okay, well, I only have 24 hours in the day. Like, where can I have the most impact?
That's
Right?
right.
And
That's
that's
right.
when I thought, okay, well, hey, you know what? Back then is when all this embedded machine learning, TinyML and stuff, like we were working on all this research and so forth. I was like, okay, maybe this can be a way to get kids to focus. It's exciting. It's AI, but it's AI in your hand. It's in your palm, right?
That's
You
right.
can get, you can understand how you can get, you say,
And
Alexa,
learn
make this
anything.
stuff,
Yeah, yeah. Mhm.
and that, and Harvard, of course, is a phenomenal institution. So I owe them a lot. They were like, even though it was like, and then there was like all kinds of COVID and all kinds of craziness, they did set up like, they took my house and they kind of made a studio and they set up like, okay, you can do this course, as long as you put it up online
Mhm.
to
Mhm.
Harvard, yes, people can take it for free and stuff. And so I
That's
ended
right.
up doing that. And then a lot of students started taking the course online, and then students would contact me. And then I realized, oh my gosh, there's actually a lot of interest from people all around the world. And so we wrote this paper called Widening Access to Applied Machine Learning with TinyML and
Nice.
stuff like
Nice.
that.
Yeah.
That's all kind of like, then I started seeing the map of where people were accessing it from, which is pretty much from every country on the planet.
Yeah, yeah, everywhere. I saw a map of your course and your foundation, and it's literally east to west, right? Like end
Yeah,
to end. You're going rounds around the
it's
world.
fascinating, right? Like once you kind of do that, then I think like I kind of, got the bug then. I was like, okay, this is awesome. Like, people are learning and growing. And, then I kind of felt like, okay, then it started sort of becoming a personal mission, going back to your question around the 1 million people.
Yeah,
Originally, when I wrote the book, I was like, okay, how do I wanted to have a metric for myself. And I always put things out and I'm like, you know what? People criticize it and that's
that's
fine.
the
That's an
goal. Sure.
opportunity for me to
Yeah.
kind of get better.
Uh-huh.
So
Uh-huh.
originally it was just like, okay, how can I get like 1 star, which is me.
This is beautiful.
So
This is
I gave
that is
myself
good.
a GitHub star on the book, which is hilarious.
That's
Um,
fine. That's okay. You should be proud of your own work. I mean, it's great work. It's great work.
no, but then it's like, it was, obviously it was very rudimentary. It was just, it's like still in shambles and stuff.
Yeah,
Then it was a goal of like, okay, can I get 10 people? And then there's a wonderful community of people that I work with on TinyML for developing countries as a group of people.
yeah.
And they were like, well, this is, of course we'll give you stars. And then we said, okay, why don't we make it like 100 stars? So it went from 10
And
to
so
100, and then it was a
9,000.
thousand last year. And I was
Yeah,
just like, okay. And then this year, honestly, I just said my
just
personal goal is
exploded.
10,000, right?
Yeah,
Like, from no
amazing.
reason. Like, it's just a metric. I honestly kid you not, it's just some fuel for me to kind of be like, okay, I got to keep pushing. I got to keep training, right?
Yes,
So, and every day, I kid you not, every day when I wake up, I do
it's
check
more
the star
stars.
count. I know it sounds tacky,
No,
but I
it's
do check.
not. No, it's not. This tells you people care. I read your
Yeah,
comment.
yeah,
This is the validation that kind of tells you, look, what you're building is actually important, right? I mean, I remember a time where we had no internet just growing up, and you could be building something really amazing, but nobody understands it. Like you're the only one in the family that, as far as the family's concerned, you're the guy that fixed the printers when it breaks. That's it. That's as far as you go, right? If you're gonna go tell them, look, I built this amazing system that can, measure performance and find data, or I built a video game, be like, yeah, great, sure.
yeah,
But when you're out exposed to a community of people that would actually, it's a great motivation. I'm telling you right now, it's a great motivation. I create content, I put content out there, and when I see people actually saying, thank you, I was able to land the job because of learning from you, or I was able to understand a complex topic in school because of you, it means something, right? Especially if
yeah,
you're people driven, it means something, right? I I have a question for you.
yeah.
Um, do you have any concerns about how AI is commercialized?
About how AI is commercialized.
Yes. So AI now is a product, right? Whether it's AGI, is it actually what we're going for? Is it the full Tony Stark Marvel, hey Jarvis, go do this and that?
Yeah,
Maybe, maybe not. It's growing. It's growing really fast in the hardware realm and the software realm, and it's starting to get involved into every other aspect of life. I feel like I'm not gonna surprised if we have like a Stanley Cup one of those days that has LLM running on it. I know that sounds ridiculous, but I'm telling you, like you know this right now. I'm telling you, people are gonna do it. People are gonna do it. You don't believe it? So,
totally. I'm pretty sure it will happen. I have no doubts that whether it'll happen or not. Yeah. So
mm, mhm.
yeah, in terms of commercialization, look, the reality is that it's no different than you know a knife in your kitchen. Sounds ridiculous, but like
Tool.
here, hear me
Yeah.
out,
Mhm,
right? Is it a dangerous weapon? Oh yeah, it is a very dangerous thing,
mhm,
right?
mhm,
What do you do with it? Well, okay, well you can do awesome things. I love cooking for all my neighbors and friends, and it's one of the favorite things to do. So yes, I actually have special knives for cooking and stuff.
mhm,
And then of
mhm.
course, then there are my kids who are like, "Dad, let me cut that thing." And I'm like, "Yeah, you're gonna cut your finger off of that thing. That's what you're
That's
gonna
right.
do,
That's
right?"
right.
But then what do we do? Do we completely stop them? No, right? Like we
No.
try to
Yeah.
understand, like, okay, what are the guardrails we have to put in place, and let them sometimes make the mistake because it's the best way to learn and so forth, right? And I think it's a little bit of that same mentality that I do have, and I will be very transparent that one of
Mm,
my weaknesses is that I'm very pro on technology, right? I get very excited. That's why I'm a researcher and so forth. But that's also why I know what I get very excited about, and
mhm,
whenever I work on something, including my admins, they know that I first thing tell them is like, these are all my weaknesses. So
mhm.
please, when I hire somebody, I specifically hire to make sure it's their strength. So they will drive me nuts about it,
That's
right?
right.
So
That's
that
right.
I can be kept in check.
That's right. That's right.
The reason I say that is because I think like that's what we essentially have to do, right? There are a couple of us who are very excited. We should absolutely build this technology. Then a couple of us who are worried about it, but we should work together to try and
Mhm,
understand it. And that's one of the reasons that I absolutely love being here academically. I'm very fortunate because Harvard is an institution that where liberal arts education is really valued. So it's not
mhm,
pure engineering. There's a lot of sciences and humanities that we
mhm,
take a lot into.
mhm,
And I feel like if we ever get in trouble as engineers, it's really because we tend to only be taught as engineers. We forget the important role of humanities and all these other subjects.
Hmm.
And
Hmm.
I think it's really important to train engineers as holistic beings, because
Yep,
then I think we start doing the right things for how do we deploy AI in the wild.
that's
Right?
right. How we actually make it useful for humanity and whatnot.
This is why in the book, for instance, Hassan, like one of the reasons, like, as you kind of go into the advanced chapters, I do have things about like sustainable AI. Like, what are the implications of this? How do you think about responsible AI? How do you think about privacy and security aspects?
I
Like,
saw.
that's the whole reason I kind of put that in. It's primarily because you want students to realize this is not optional. This is just fundamental to kind of
That's
like,
right.
what actually happens. And one of the
Okay.
reasons, by the way, the book is so long is really because the credit also goes to Marcelo, who actually commented on it, I believe, in your thing.
Yes, yes.
He's a
All these.
phenomenal person as a professor. Like, he's the one who actually helps do all these labs. He loves doing the hands-on components, and we kind of package things up together. Like,
Hmm.
and
Hmm.
we do, I do work with him and all these. Yeah, I mean, there's a fun set of people, and I think like the community is pretty incredible.
That's the thing. If something catches fire, like something just goes viral and everyone is interested in it, just people are gonna come out of everywhere, like people you didn't even know you could possibly meet. And that's
Yeah,
the beauty of this whole thing. Well,
yeah.
tell me, well, you have the book, but
Hmm.
you also have the course. Tell me a little bit about the course, Professor.
Which particular course are you talking about? Are you
That
talking about the TinyML course?
Yeah, the TinyML course. I'm very curious about tell me a little bit about the course, what people would learn out of it.
Hmm.
It has 100,000 people interested in
Oh
it.
yeah, yeah.
Tell me a little bit about that. Go ahead. Go ahead.
Yeah, so this course is really about like the idea that you can actually deploy ML on embedded devices, right? As we were talking about earlier, you can
Hmm.
have the brain, but without the nervous system, it's pretty much useless, right? I really
Hmm.
think the next big frontier for a lot of these frontier models is really understanding the physical world.
That's right.
That
That's
is,
right.
they're amazing at understanding the digital world. They will continue to knock it out of the park,
That's
but
right.
they
That's
do
right.
have a big void and an air gap in understanding what is happening in the physical world.
That's right.
And
That's right.
but to understand the physical world, you need a lot of telemetry and data that's coming through, right? And embedded machine learning, or TinyML, is really one of these things that kind of grew out of like the TinyML Foundation and Pete Wharton, and when we were at Google and so forth, there
Hmm.
was this moonshot about trying to put ML onto an embedded microcontroller, right?
Hmm. Hmm.
Um, that's what this course really is about. How do you package up ML onto tiny little cheap microcontrollers that cost about 50 cents, right?
Okay.
And
Okay.
so students basically go from understanding the fundamentals of machine learning, just kind of like, the theory and like, what is a, MLP, how do you think about losses and
Yep.
gradients, and so forth. And then to kind of get into what are the applications of TinyML? Like, where is it useful? Well, it's clearly in your watch. It's clearly in
Yep.
your Alexa and all so forth.
It's on the go. It's mobile. It's
Yeah,
not that big mainframe or
exactly.
massive. I'm guessing also like something like this. I am big on LLMs offline, like just have your own intelligence at your home running. You get to control it, you get to modify, you get to do whatever you want with it. I feel there's power to
Yeah.
that, and I feel courses like these kind of gives you even more power into not just using it, but understanding it and whatnot. Um,
Because you
um,
start appreciating the system's constraints, right?
exactly,
Because these things are,
exactly.
only a few hundred kilobytes and so forth. So you got to get a model that literally fits in this dinky little chip.
That's right.
Like, it gives
That's right.
you a much deeper appreciation of, oh, you can the fundamental you can talk to a data center operator. They will tell you data center is a resource constrained system,
Yes,
and they're
yes.
100%
Despite, yeah, yeah.
100% correct,
Uh,
right? And it's effectively like taking that fundamental concept and kind of like distilling it down to like something you can put in the palm of your hand, right? And be able to teach this without having access to cloud computing and all that. And so
mhm.
that's kind of like what sort of like is at the heart of this thing.
Okay, okay. Well, let me ask you this. Tell me what your vision of the future of AI is. Tell me
Mhm.
things that haven't happened yet, but you have like a hunch. You feel like this is going to happen. People don't talk about this enough. What are the advantages, things, maybe disadvantages? I don't know. Just tell me a little bit about the future and what you think about just seeing the trajectory of growth in that particular field.
And it's like I'm going to talk about it more from a practical standpoint than kind of talking about it from an AGI standpoint and so forth, right?
Hmm.
I would say that I mean, I just imagine you just kind of walk into your house, right, after a day of work, and you literally do have the LLM basically asking you how you're doing and sort of able to understand, how you're really feeling because you have all that embedded ML sensing, and that it's able to actually understand the data, not just have a threshold, but it's able to understand what your day was like. Pretty much like, how, my wife will say, how was your day? Right.
Yep.
Now, the pros and cons about, having AI do all this stuff, but I'm saying like we're inevitably going to realize that, right? Because you want the environment to kind of blend around you. And I see like that's definitely going to happen. I think like, my kid, I'm pretty certain that she is going to have a personalized AI that she interacts with. I mean, you
In
should
her day
look
and
at
time.
the way
Yeah. Mhm.
my kids interact. When I use Google search, they look at me like I'm some old grandpa.
Right. Right. You should tell them you're older than Google and just see the face impression. I they just can't imagine the world without Google. Like, how did you guys even survive?
Yeah,
How did you find anything?
yeah. But in her head, whenever I go on to Google.com, she's like, Dada, why are you using Google? Just use ChatGPT, right?
Ah,
Like Gemini, sure, but you know how it is. Like it's like,
yeah, sure.
ChatGPT is basically the new Google word for all these
Yep,
systems, right?
yep.
But she and her friends pretty much live in a generative world already. Whether we like it or not, she knows about hallucinations and all this. I'm like, where are you learning all this stuff? Right? She's 10 years old. Like she
Yeah,
knew, like when nine already, she already knew this. And she was like, oh, they teach all this stuff at school. So, you can use the same prompt, but the prompt doesn't really realize because it doesn't generate the same thing. So, it's like she
that's
used
right.
the word like, oh, it's a probabilistic system. I was like, what? Like, do you even know what probability is?
Do you even know what that means?
So I
What?
think
Yeah,
inevitably, right? If they're already so invested, like, you should see the way she'll kind of like have an idea and then she runs it with a story. Like, we're actually doing a fundraising thing on Saturday,
nice,
and she's
nice.
making all her stuff and she's totally using generative AI to create her pamphlets, and she interacts with it back and forth and all that stuff. And so if they're already doing this, by the time she goes to college in like another 8 to 9 years, I fully think, ChatGPT, whatever version, is going to be fully aware of, how my daughter thinks, probably even better than I do because of all the things that she'll probably tell it, right? So I
That's
think like
right.
that's going to be kind of the world that we're in. And I think
Yep.
like the biggest thing I would think is like the connecting to the physical world.
Gotcha. Gotcha.
This has always been a limiting factor for traditional IoT
Mm-hmm.
because you
Mm-hmm.
have to explicitly use rule-based mechanisms to program to draw out an insight.
Yep.
That problem
Yep.
is fundamentally solved now.
Gotcha.
So now
Gotcha.
you take that IoT fabric with all the cloud computing capability for the brain, and if you take the IoT fabric, and this is where I was saying, you've got the brain,
Uh-huh.
now
Uh-huh.
you've got a nervous system that already exists.
You're just leveraging that. It's
Now
already
you got to
there. Yeah.
connect these
Hmm.
two, and that's when I think it's going to be a one heck of a world because everything is just going to be speech driven. I don't think you're necessarily going to be flipping this and that, and like I think everything is pretty much just going to be speech driven because
That's
it's
right.
more fluent.
Jarvis. Just talk
Yeah,
to Jarvis. Have you
yeah,
ever watched the movie Her with Joaquin Phoenix? I
yeah.
feel like when I saw this first, I saw it a long time ago. I was like, yeah, I guess we could get there at some point. I just don't see it in maybe 20, 30 years. But now, if you have someone who've never watched this movie, look
Yeah.
at it and watch it, and is like, he's talking to his operating system. He didn't like I noticed like in the movie, it's very rare that I actually sat down and actually started typing anything except when he's at work sometimes. But
Hmm.
most of his interaction, his human machine interaction is all vocal. It's
Yeah.
all voice,
Yeah.
right? And it can see him and he can show the machine things and it doesn't really have any form. A little bit concerned about people building robots that look just like humans and putting GPT in it and have you seen some of these? Have you seen the Neo robot? It's I'm just surprised. I saw this robot, a Chinese robot that just walks very flawlessly
Oh
and
yes, yes,
nicely.
yeah.
Oh my God. I was like, there's definitely someone in there. And then the guy just started
Yeah, the guy cut it.
unwrapping.
Yeah.
It's like,
Yeah.
what? I couldn't tell if that's like it's like the uncanny valley. Like, this is a robot, but your just brain just can't wrap around it. It's just very
Hmm.
hard to tell.
Yeah.
Um,
There's going to be another Turing test on this.
Oh my God, really?
There's going to be
Uh-huh.
a Turing test on this that I bet you will be like, okay, from Turing test is purely digital, right? It's like this algorithm.
That's
Now
right.
we're going to have this as like, well, can you actually open the skin up and see, oh, it is a physical thing? Can you actually tell by the movements and the gestures and so forth that whether
Oh
it's
my
actually a
God.
human being or is it actually a robot? I bet you someone's going to have a Turing test on this.
Yeah, they must. I mean, I know that it's gonna be really. I mean, right now, like the classic Turing test, putting a human and a machine behind a curtain and sending a question. Right now, AI can definitely fool anybody into thinking this is a real person. I was playing with TTS, like text to speech models and whatnot, and the creepiest thing, like just my old me kind of. I was giving it text to kind of narrate and just say, and it's breathing. Professor, it's breathing. It's
Yeah.
taking a breath. It's not taking a breath. I know that it's not taking a breath, but it's breathing. You can hear the breath as it's narrating and saying things. I was like, whoa, that's insane. And that's just like open source thing. You can play with, imagine what's actually in the R&D and what's being worked on and whatnot.
Hmm.
Um, I wanna close with two things,
Yeah.
right? You are someone I actually can talk to forever. I have so many things I want to ask you about. Expect your LinkedIn to just be bombarded with questions. I'm sorry. You did this to yourself. You went to the open source space and now everybody's coming out of the woodwork. But two things for you. I
Yeah.
want an advice from you specifically to software engineers who are, just looking at this field and they're not sure and all that in general. And then I want an advice that's more generic about dedication, hard work. You have such zeal. I'm so appreciative of you. I'm happy that people like you exist in our world. I want you to give an advice also about how to keep going, how to keep pushing, because you are the perfect kind of millennial kind of scenario for everybody because you got the kids, you got the wife, you got the job, you got everything going on, and you're still pushing, man. It's not stopping you. I want that kind of advice from you. Advice for software engineers learning AI, and then advice for everybody about motivation, please.
I think like in terms of advice for AI, it's like, yes, we all use these systems, right? No doubt about that. I think the beautiful thing, I have learned from looking at other people's, open source materials is like creating those workflows. And I don't think like we really appreciate what Claude Code and so forth are truly capable of doing. Like I know we get skeptical about it, but I think until like you create the first workflow where you're actually seeing the agents kind of not just breaking its own task down, but it understands your skills and how you actually, but you have to learn how to do that, right? It
That's
doesn't
right.
quite, it's capable of that, but it doesn't necessarily guide you to say, okay, would you like me to create a workflow for you? This is how you should section your skills. They don't quite do that, right? But they
Mm,
understand how to execute that. And I
that's
think
right.
for a software engineer, I think realizing that I think is the first thing. They obviously know you can wipe code and so forth. Well, now, wipe code has got a certain flavor to it, but I
That's
do
right.
think once you start understanding how to structure your PRDs and all those documents, and then you start understanding how to unleash the agents in parallel on those things. It's when I started doing that myself, and that's when I realized I was like, okay, I think we're actually on to something really, really, really big. And
Yes.
I by
Yes.
no means would think that we're gonna replace software engineers. I just think we're gonna upscale them. Like
Just
everybody
upscale.
we're gonna
Yeah, exactly.
like even I
Exactly.
learn, and I think it's just the productivity is gonna increase. I think
That's right.
anybody who says, "Oh, we're just gonna like completely be able to replace them," I mean, yes, a little bit of that inevitably will happen, right?
Yeah,
Because
the redundant kind of
yeah,
no-brainer.
yeah,
Like if your only thing in the software industry is literally to build databases and connect code to databases, this is gonna get
yeah.
completely. I mean, even without AI, like you have ORMs, object relational models, and you just write kind of C# code or Java code, and it gets turned into a database table and whatnot. That's what happened. You used to have DBAs, database administrators, and most
Right.
of them are gone, right? Where did you go? Where did they go? They became DevOps
That's right.
engineers, right? So that progression and evolution, that's what you're saying,
Yeah,
basically. Mm,
yeah.
mhm,
And then in
mhm.
terms of going, I mean, in all honesty, I wish I could kind of give a very clear answer. For one, I know it's the community itself. Like, like I told you shamelessly, like when I get up in the morning, one of the first things I do,
Check
honestly,
the
is
stars.
just it's not about how many stars I get, like in all
It's
honesty.
just more. I got more. That
Like if
some
I get
more
even
people
one
saw it.
star
Mhm.
for me, it's like, okay, somebody, someplace is looking at this for
Yes.
whatever reason. And I remember when I was a student once, um, as an undergrad, reached out to a Stanford professor and about genetic algorithms and so forth. And of course, he doesn't have time and so forth. I'm some rookie kid, just sending an email,
Mhm.
and he shipped me. back then he shipped me two cassettes, like VHS cassettes, on
Wow.
watch them.
Yeah. Yeah.
And and he actually signed on the packet. Of course, I'm sure he didn't go to the mail and stuff. I'm sure his admin did it or whatnot.
Someone did. Yeah.
But you ask like, why do this stuff? It's because people have done it for me.
That's the thing. Like we are the, you know, I was literally just talking about this the other day. I was telling people like whatever we are today, that's because the amount of people that decided to do something for us expecting nothing in return. Like no matter how much you think of it in terms of like a product and you buy the product and subscribe the product, if you actually look at your life in general, and this is for everybody really, it's crazy amount of hours that were given to you for
Yeah,
free with
exactly.
nothing in return, starting with our parents,
Yes.
right? Just tireless nights, just making sure you're healthy and you have the right education, whatnot, and all the way up until this moment, everybody along the way. And it kind of scaled with the internet, with the open
Yeah.
source, with having resources online, amazing, beautiful people like yourself that just put that out there and be like, maybe someone will read it and it will benefit and they will
Yeah.
benefit from it.
Same thing,
Mhm.
right? So that's why I do it, is because people did it for me, and I feel like I'm at a point where, okay, now I'm being productive.
You're
Now
passing
it's
it
my turn
forward.
to kind of pass it on to get the next generation on board. And it's as simple as that, in all honesty, Hassan. It's pretty simple. So
One last thing. One
yeah.
last thing. What keeps you up at night these days? What's an idea or a concept that's new in this world that's keeping you there? Yes, this I got you excited there. Tell me, tell
Okay.
me what's the thing that's keeping you up these days? Mhm.
Okay. Here it's you have to open this and I'll
Yeah,
explain.
I'll open it. Yeah. Mhm.
Okay, so here's the link. It's a riff on the book, obviously.
Sure.
Just click it and I'll explain what.
Will do. Will do.
And then
Here
if
you
you
go.
share it, that'll be good because people will understand the context.
I have a feeling this is gonna be good. Here you go. Tell me.
All right. So the book is basically about, the machine learning systems book is kind of like all this theory and all this stuff, right? But one of the things that I realized is that, oh my gosh, like it's like you can take class, you can understand the concepts. Yes, they're engineering concepts and so forth, but you got to go out in the lab and build it, right?
Hmm.
And that's what this is. This is something I've been working on, and I intend to really quote unquote. It's already open source, as I was saying. I put everything out, even as I'm working on it.
That's right.
TinyTorch is really about understanding if you use PyTorch, what actually happens behind the scenes. So if you look on the left side, right, of the
Hmm.
navigation bar, like
Hmm.
you see the foundation tier. You
Everything. Yeah.
start from
Hmm.
basically having a very simple array to understanding
Nice.
how you do activations, how you build on layers. Layers then go to losses, right? What are the optimizations you're performing? How do you do back propagation with auto differentiation, right? What does
Amazing.
Atom really do as an optimizer? And here's the beautiful thing. So every class out there, does have these concepts. You do get taught these things in abstract, okay?
Yeah. Yeah.
But the big thing, when we took compilers and so forth, is that you started from an empty file kind of a thing. But at the
Hmm.
end of the day, every one of them is building. So it actually compiles. So literally, as you kind of progress through this, you can run the MLP thing. You can run the transformer. You will get to the transformer. You'll actually run a small little transformer. So basically,
Hmm.
you're building a full PyTorch by the end of it.
Your own kind of yeah,
Yeah, it's an
wow.
educational framework for certain, yes, but it's not meant to compete or anything like that. Like, you
It's the
learn about
foundation. It helps people understand how this thing works, basically.
exactly, and it's all collab and so forth. And so it's like at the end of the day, as you progress through every module, it literally starts mimicking what PyTorch looks like. So my vision is basically this is why right at the beginning I say, it's like from tensors to systems, right? You should be able to look at TinyTorch as you kind of build it, and then when you go to PyTorch, you're like, I know exactly what this thing is doing. Sure, there'll be bells and whistles, but largely, I fundamentally know exactly what
This
it's
is
doing.
yeah.
And this
Yeah.
is what I'm super excited about. Not just because this I and one of the cool things about this is this like is then going to be like I'm working on this packaging actually right now. I want
Uh-huh.
to create a community where it's like, when people install it, they become part of a leaderboard, so
Yeah.
then they're able to do their optimizations a little, they can optimize their quantizer or they can optimize, how they do pruning or something as they learn these concepts. And
Yeah.
then they're able to basically compete. So then imagine we actually have like a community of students all competing online, and there's a leaderboard for it. Everybody's part of it.
Amazing.
So it's basically like that. What I call is like the AI Olympics is essentially what.
Yeah, gamification. You're gamifying it and you're
Yeah,
making it more. I just also saw something very interesting here. You're really mean this. You're building like career impact by tier, foundation tier, graduate, architect, optimization tier. And I saw just a second here, turning a software engineer into an ML engineer. Just a
Yeah.
moment. There it is. Software engineers being ML engineers, transitioning into ML engineering. Oh my God, you're something amazing. You're just a blessing to this
I feel like,
community.
kind of like once you start doing this, then the next generation will really kind of understand how these pieces all kind of build together. It's like there's nothing like, you can say like, oh, I'm driving a car, but it's very different when you say I can build a car.
That's right.
Right?
Very different.
Yeah,
Very big difference.
that's fundamentally what I'm going after here. That's why I say like, the catchy phrase, tacky is, don't just import it, build it, right?
That's right. That's right.
Yeah.
Um,
Anyway, that's what
Vijay,
I'm really excited about.
I really appreciate you, Vijay. Yeah, I appreciate you so much. You are such a blessing and amazing person for the community and for the world in general. And your contributions and what you build are very, very highly appreciated. Like I'm telling you, I'm just one person, and I'm looking at everything you've been doing, and it's just outstanding, amazing. And I'm gonna follow you. I'm already following you on social media. I'm gonna make sure you get that star, make sure that you get that like, and it's just my way of saying I see what you're doing and I love what you're doing, and please keep doing it because it means a lot. You're lifting an entire industry up to the
Yeah.
next level. You're helping a lot of people get into that new era, which is a lot of software engineers definitely need. A lot of smart people. They just need to know where to get into the field and be able to help out and expand there. And for people watching, I hope you really enjoyed this conversation. I've learned a lot. I'm just looking at everything Vijay is doing, and it's just really amazing. And if you have any questions, comments, concerns, I'm gonna make sure I drop the links for Vijay's profiles, MIT, sorry, Harvard profile, open source book on GitHub, and all the courses that I can have, and all his social media handles and all that. And if you have any questions, comments, concerns, please feel free to drop a comment in the comment section. And don't forget to like Vijay's stuff first and then like my video second, and subscribe. Thank you so much. I appreciate you, sir.
Thank
Take
you,
care.
Hassan. I really
Take care.
appreciate it. It's
Yeah, I
absolutely wonderful.
appreciate
I
you.
love connecting with folks like you. Thank you
Thank
so
you.
much.